The normal distribution. So first, let's review the different types of distributions we actually learned earlier in the year. So one of them was normal. So normal is what you see in that picture below. But normal has one mode. It's evenly distributed on the left and the right. Bimodal is when there's two peaks. So it has two modes. So this would be a bimodal distribution. Usually means that you're pairing together two data that should be separated because it represents two different types of groups. Skewed left looks like this. So this is skewed left. There's a tail on the left here, right? And skewed right would obviously just be the opposite of that, so drawing that opposite picture. Okay, the definition of a normal distribution. The normal distribution has a bell curve where the data is concentrated around the center and then symmetrically distributed out from the center. So we talk about the 68, 95, 99.7 rule. So just to tie this together, we're only looking at the normal distribution here, okay? So this is for things we expect to be normal. If this was bimodal or skewed left, none of these rules are going to apply the same way. So the 68, 95, and 99.7% rule essentially says that this data should represent 68% of your data on a normal curve. This data right here should represent 95, and this data right here should represent 99.7, which means there's some data on the outside here, right, which represents 0.3% or 0.15% is over here, and then over here is another 0.15%, right? So there's some data off on the side there. So if it's symmetrical, we also know that this 68 should be divided in half on either side. So this would be 34 and 34, okay? Which represent, then that means that this should be 95 or 47.5%, which would leave us with 13.5% on either side of this. Again, this just representing that red area there. And then lastly, if we subtract 99.7 and 95, we get 4.7, so about half of that. So 2.35% should be in this yellow region right here, and 2.35% should be on the left yellow region as well. Okay, so ideally that's what a normal curve looks like. That's how it's set up. We can make things into a normal curve, but sometimes things naturally fall into that normal curve. All right, so what you're going to do is you're going to try out an experiment where you flip a coin, and you flip that coin 10 times, okay, and then you're going to write out how many tails you get, okay? So our focus is on tails, and what it should say here is you flip a coin 10 times, and then do this 10 times, okay? So in total, you're going to flip a coin 100 times here in the next few minutes. So it's a pretty quick process. You just got to take a coin, flip it 10 times. You're going to count out how many tails, and then if, let's say, you have 3 tails, you're going to put a tick mark there, and do that 10 times so that you have 10 ticks all over this place. You might have a couple here, you might have a few there, whatever it is, okay? So you're going to fill that chart in. Once everyone in the class is done, you're going to collect everybody's information, and you're going to say how many zeros did we get, how many ones did we get, how many twos in total. So if there's 20 of you in the class, we should have now 200 experiments, which is awesome. And then you're going to convert this to a percent. So if there are 200 people, I don't know how many people are in class, but you're going to use each other's work, okay? And there was one person who got that. This would be 1 divided by 200, and you'd write down your percent there, which is 0.5%, if that happened, okay? And then you're going to take this data here, okay? And then you're going to make that into a graph where you're graphing X is the number of tails. So this is going to be your tails. Don't copy this down yet. And then this is going to be your probability, okay? And you're going to see what the shape of your curve looks like. So this is going to be 0, 1, etc., all the way up to 10, and you're going to have just a graph that looks like that in the end, okay? So that's what you're working towards right now. Yeah, so this is the normal distribution. It gives you a good introduction to it. Should find on your first graph, it might not look very uniform. Sorry, not on your first graph. On your counts, it might not look very nice and uniform because you're a small number of trials. The more trials you do, the better this distribution could look. And then we should see a nice graph here at the bottom. That's what I want to see from each of you at the end of this work period. All the best with the normal curve.